else can you say it? 0.12, how else can you say it? 12 over 100. There's another way to say it kind of like that.
12.
He said 12 over 100. What's the other way to say it? Say it. 12 hundredths, right? True. So every single way that we all said it was right. But whenever you want to turn this decimal into a fraction, you can literally use those words and make it into a fraction. So I'm going to say this is 12 over 100. True? Okay, now, what's the other part of this that we need to do? Simplify. Why do we need to simplify? The lowest form, right? And whenever you're taking a test, you might not see this answer because this is not the most simplest form. So you need to know how to get it to the most simplest form so you can pick the right answer. Because stuff like that is going to be in the most simplest form. Okay, how do we simplify this? What do we need to find first? Yeah? Common factor, and we want the greatest common factor, true? Okay, sometimes with these bigger numbers it's hard to figure it out unless you just draw it out. We can draw it out, but there is one common factor that I know that they have. What is that one common factor that we already know they have?
2.
Because they're both even numbers, right? So I can divide it by 2. Is there another number that I could possibly divide them both by that's bigger than 2?
Maybe
4? Okay, so let's try 4. What's 12 divided by 4? And 100 divided by 4?
25.
25, right? There's 4 quarters of a dollar. Now, from here, 3 over 25. Can I go any further than that? What are the factors for 3? 3 and 1. Does 3 or 1 fit nicely into 25? Is that the same factor? Does that have the same factors as 25 does? The only thing they have in common is the 1, right? Okay, so that's as far as we can go. So on number 19, you turn this into a fraction, you simplified the fraction, your answer is 3 over 25. And I'm writing it like that because whenever you put it in your form, you'll put it like that, right? Okay? Alright, go to let's do number 22. Okay, I'm going to skip number 20 and 21 for right now. Number 22. We are going to put these numbers in order from least to greatest. Okay? We have some decimals and we have some fractions. They all have the same whole number though, right? The whole number is what?
8.
On all of them it's 8. But I cannot figure out who is bigger than who if they are all different types of things, okay? There's fractions, there's decimals. Fractions and decimals are both considered rational numbers, right? Rational numbers are the pieces, right? They're both considered rational numbers, but because they're not the same kind of rational number, we have to make them the same kind of rational number before we can actually put them in order. Apples and oranges are both what? Fruit, okay? Apples and oranges are both fruit, but is an apple the same thing as an orange?
No.
Okay, they're the same type of thing, but they're not actually the same thing. So I can't compare how big these oranges are compared to these apples because they're two different things. Same thing with fractions and decimals. They can be the same thing, but they can't be the same thing if they're not in the same form. That's kind of confusing the way I said it, but you get what I'm saying? They're the same thing, but they're written two different ways. We have to write them all the same way before we can figure out who is bigger than who. Alright? Let's start with, do we want to change them all to a fraction, or do we want to change them all to a decimal? Does decimal seem easier?
Yeah.
It is for me. There was a kid yesterday's class that she didn't want to turn them into a decimal. She wanted to turn them into fractions. And I was like, if that's easy for you, that's easy for you. For me, it's easier to change it to a decimal. Because if I don't know, I can just divide the fraction, and that automatically gives me the decimal, right? Alright, so we're in agreement that we're going to change all these into decimals, right? Okay. 8.85, do we do anything with that right now? 8 3/4. Okay, so what do we need to do to 8 3/4? Change it to a decimal. Now, some of you already know what 3/4 is, just because it's one of those benchmark fractions that you already know what it's gonna be as a decimal. Do we already know what it is as a decimal? What is it? 0.75, right? What if we didn't know that? How could you do that? How could you figure it out if you didn't already know that it was 0.75? What is the process that we do? What's that strategy that I told you to use? Cowboy and horse, right? What we're doing is we're gonna divide the top by the bottom. Yes? We're seeing how much of the first goes into the second. So we're gonna say 3/4 is really 3 divided by 4, yes? That's a little bit ugly. Okay, 4 won't fit into 3, true? So what do I have to do to 3?
Turn it into a decimal, add to it.
Add to it, turn it into a decimal. We'll put the decimal here, and then what do I put after?
A 0.
Okay, and then before I do anything else, I need to make sure I pop this up, so I don't forget. Yes?
Yes.
You on the same page? 4 won't go into 3, you already said that, right? So I'm gonna put a 0 there. What about 30?
6. 5.
Do your fours. Do your fours. 7. What's 7 times 4? 28. Subtract it. Then what do I do? Here? Then? Drop it.
5 times
5?
4. 5.
It won't go anymore. That's that, yes?
Yes.
So my answer is 0.75. I would attach this back to the 8, and I would get 8. So on your paper, just underneath the 8 3/4, I want you to write 8.75. If you want to rewrite that one too, you can, if you want to keep them all online. Okay, is 8.5 good?
Yes.
We're going to keep that one, right? What about 8 3/5? We can do the same thing, right? How do we check that though? What if we do our math on this and we're not sure if we got our math right? So that's gonna be like this. And I'm gonna do the same thing I did earlier, right? And I'm gonna get 0.6. But what if we're not sure that we did our math right? I'm gonna draw a fraction bar here, okay? Pretend like that's all perfect. And I'm gonna cut it into fifths. Pretend like those are perfect, okay? I'm gonna shade in how many of these? 3. Okay? Now I'm gonna draw a number line. This is gonna be 0, this is gonna be 1. What is gonna be right here? Right in the center of 0 and 1.
0.5?
Okay? So 0.5. Does it look like this is about 0.6?
Yes.
Now, I did kind of make this wonky, right? But it looks like it is about there. So that answer is probably correct if you wanted to look double check this way, right? So now we're gonna have 8.6, yes? Okay, and then we can use this same thing we just did. Let's leave our 0.5 there, okay? And then, let's draw another one. What's the next one that we need to convert?
8 and 2/3.
We need to convert to 2/3. How many of these do I need to fill in for 2/3?
2.
Okay, and if you were, for time's sake, if you were to do the math on this, 2/3 would give you, do you remember what that one would be? 2/3 as a decimal? Repeating, right? So it'd be 8.6, and I'm gonna round it to 6/7. Okay? It's gonna repeat, but I'm gonna round it to 6/7. Now, we said this is 2/3. 8.67, is that gonna hit about the same spot? Because I'm gonna say 7/5 is probably about right here. So do those hit about the same spot? So we would know that that one was probably true also. That's another way that you can double check, just to see if it lines up right for your fraction bar and your number line. Now that we've done all this, we have to take all these and